Hello, welcome to this video. This is 2-5 and we are going to make derivatives a whole lot simpler in this video. We're going to start out talking about the basic fundamental derivative rule in calculus, which is called the power rule. You're going to love this video. I'm going to show you why here in a moment. Alright, so reminder, given a function f of x, the derivative of f of x is denoted as f prime of x. That's how we say it, f prime of x. And we have showed you up until now that f prime of x is found by taking the limit definition, the limit as h approaches 0 of f of x plus h minus f of x divided by h. And remember, this is just derived from taking the average rate of change and moving that second point in the average rate of change closer and closer and closer and closer to our initial point where we want to calculate the instantaneous rate of change at that point. The problem is that this is very, very tedious, time-consuming. It requires strong algebraic skills. Now, we wouldn't want to go ahead and use this for all of the derivatives throughout this course because, quite frankly, the simplification is not even possible with all the types of functions that we're going to go ahead and encounter. So we're going to learn some derivative rules that will help us calculate the derivatives, the slope at a point, the slope of a tangent line at a point, extremely, extremely quickly. The first one on deck for you guys is called the power rule, and it has to do with the powers. So here we're going to go ahead and define a function. If f of x is equal to x to the power of n, then f prime of x is equal to n times x to the power of n minus 1. I multiply by the power and I subtract the power by 1. That is the power rule, and it's very, very simple and very, very straightforward. This only works for polynomials, though. Does not work for sine and cosine, does not work for exponentials, does not work for logarithms. So we're going to have to go ahead and use this strategy appropriately, okay? Now, note number 2, make sure that x is in the numerator before using the power rule. We want to make sure that our x is in the numerator, and I'll show you some of those examples here in a moment. Okay, so example number 1. Given f of x below, go ahead and find f prime of x, and then they ask us to find f prime of 3. I'm going to cycle back to f prime of 3 just because I want to get us flowing here with this idea of a power rule. Okay. If f of x is equal to x cubed, we want to go ahead and we want to find f prime of x. Okay, so I'm going to use the power rule. I'm going to multiply by the power, 3 times x, and I'm going to decrease the power by 1. I'm going to subtract 1. 3 minus 1, what is that, class? Very good, 2. 3x squared, there's the derivative. Oh my gosh, wasn't that way easier than using the limit definition? Man, I know you're hating me for those couple of days that we spent agonizing over the limit definition. B, f of x is equal to negative 3x squared. What's f prime? Well, I'm going to go ahead, I'm going to multiply by the power, so negative 3 times 2 is negative 6. X to the power of 1. I mean, you don't have to write x to the power of 1, negative 6x. There's your derivative. That's it. That's it. C, f of x is equal to negative 5x, just 5x. F prime of x, okay, I'm going to multiply by the power. 5 times 1 is still 5, and then I'm going to drop the power by 1. And off to the side here, I'm just going to write this. X to the power of 1 minus 1 is x to the power of 0, which is just 1. So anytime you take the derivative of a linear function, it's just constant. And this should make sense. Look at this function. Think about it if you were to graph this. Y is equal to 5x. Isn't that just a linear line with a slope of 5? So the slope for everywhere on that line is just what? 5. That's it. Very, very straightforward. Okay. D. Oh, we're going to start to get weird here. F of x is equal to 5. x to the power of negative 2. Well, I'm going to go ahead and I'm going to multiply by the exponent. 5 times negative 2, that's 10. X, and then I'm going to decrease the power by 1. So instead of negative 2, we get negative 3. Now, if the instructions were to say something like, make sure that all variables have positive exponents, okay? Here they're wanting us to go ahead and they would want us to use the negative exponent property. And just to refresh your memory here, x to the power of negative 2, this is 1 over x squared. If you have a negative exponent, it's going to move either from the numerator to the denominator, or if it's negative in the denominator, it will move up into the numerator and the power just becomes positive. And here's an example. This would become negative 10 over x cubed. Now, when would you want to do this and why would you want to do this? Well, you would want to do this if you're going to compute something. If I'm going to go ahead and plug in 3 down here, oh wait, didn't they want me to do that? F prime of 3. I want my exponent to be positive so I can compute that. So negative 10 over 3 cubed, that's going to be equal to negative 10 over 27. There is f prime of 3, right there. Ta-da! There you go. E. F of x is equal to 7. Okay, well, f prime of x is equal to 0. What? Schwarberg, you didn't even use the power rule. I know, this is a constant function, and I need you to think about this conceptually for a second here. I'm just going to sketch really quickly. Isn't this line right here, y equals 7? I know it looks like an asymptote, but I'll just do this. So this is y, this is x, this is 7, right here. What's the slope of a constant function? 0. It's a flat line. Okay, so whenever you take the derivative of a constant, it just becomes 0. Pretty simple, right? Okay, and thus likewise too, f prime of 3 is going to be equal to 0. Everything is 0 for that. All right, ooh, fractions. Fractions, you guys ready for fractions? F, you looked at this problem and you're like, F! This is F. And the function's called f. Okay, f of x is equal to 2/3 x to the power of 4. So f prime of x, I'm going to go ahead, I'm going to multiply by the power. So 2/3 times 4 gives us 8/3 x to the power of 3. Nothing complicated there. F prime of 3, if I'm going to compute this, this is 8/3 times 3 cubed, which is 27. So 8/3 times 27. Hey, let's do some cross cancellations. Becomes 9, and we get 72. Sweet. What's mine say? Dude. What's mine say? G. F of x is equal to x to the power of 4 over 6. Over 6. Okay, here they're just trying to be cute. What you can do here, this is 1/6 times x to the power of 4. So now when we go ahead and do our f prime, I'm going to multiply by 4. That gives me 4/6 x to the power of 3. And I can reduce the 4/6. This becomes 2/3 x cubed. So there's your f prime. When would I want you to simplify? Do I have to simplify? That's a common question. If we're on like a free response problem, go ahead, stop here. I don't want you to make mistakes. So even doing, and you're like, sure, come on, 4/6. Everyone knows that's 2/3. Well, what if you're just off in that moment? Okay, so stop here. If it's a multiple choice and you need to compute or you're looking for your answer, most likely you're going to have to reduce. So it all just kind of depends. Again, okay. F prime of 3. F prime of 3. So I have 2/3 times 3 cubed. This gives me 2/3 times 27. Again, this gives me a 9, so we get 18. That's f prime of 3. Okay. Let's see. I'm going to have you go ahead and pause me. I want you to try H and I on your own. Please pause me. H and I will be on your own, and I'll show you the answers here in a moment. All right, hopefully right away you did some transformations on these. This is 3/2 x to the power of 4. This is 3/5 x. And I'm going to go ahead, in order to do the derivative, I'm just going to use my power rule. I'll multiply by the power. So I get 12 over 2 x to the power of 3, which reduces to 6x cubed. And then over here, f prime of x, this is going to just be equal to 3/5. It's the derivative of a constant. So you just get, or sorry, the derivative of a linear function, which is constant. So over here, f prime of 3, that's going to be 3/5. Everything is 3/5 for that function, for that derivative. And then over here, f prime of 3 is equal to 6 times 3 cubed, 6 times 27, which 120 plus 42 gives us 162, I think. Don't be mad at me in the comments if I got that wrong. I think that's it, though. You know what I was just thinking, too? Did they want us to find f prime of -3? No, f of 3. We're good. We're good. Okay. All right. Moving right along. The last 3 that I have here for you in this video, the last 3 that I have for you, I have multiple terms. Oh my gosh, Schwarberg. I have multiple terms. What do I do? Well, you're just going to take the derivative of each of them individually. And this is a derivative rule. If I'm taking the derivative of something that has multiple terms, I can take the derivative of each one individually. Now, before I can go ahead and show you this, I need to go ahead and I need to execute note number 2 in our notes, which was make sure that the function is in the numerator before we begin. So, or the variable is in the numerator. Do you guys see this x right here, how it's in the denominator? I got to move it up. It needs to be in the numerator. I can't use the power rule if variables are in the denominator. So this becomes x to the power of -1 plus 2x squared. And then now I'm going to go ahead and take my derivative. I multiply by my power, so -1 times 1, so -x, and I subtract 1 from my power. 1 minus 1 gives me -2, plus 4x. Okay? And again, if you want to get rid of that negative exponent, if you want to rewrite f prime of x, this is going to be -1 over x squared plus 4x. Okay? So there is the derivative. And continue with this, f prime of 3. So -1 over 9 plus 4 times 3, which is 12. There you go. Okay. Same deal here. You know, they're trying to get cute, putting these variables in the denominator, but they're not phasing us, right? I'm just going to make it a negative. Minus 2x to the power of -3 plus 3x minus 7. Okay, so this is f of x. And then now I can go ahead and use my power rule. Derivatives are easy, Schwarberg. They are. It's really easy. Just multiply -2x to the power of -3. -2 times -3 gives us a positive 6. X to the power of -4. Ooh. Derivative of 3x? 3. Derivative. The derivative of -7, that's nothing, 0. I'll put nothing here if you want. The derivative of -7 is 0. Do I need that? I don't need that. I'm getting rid of it. Okay. And then I'm going to go ahead and just clean this up. -2 over x cubed plus 6 over x to the 4th plus 3. Okay. Hey, you're on an AP FRQ, and they give you this function. They say, what is f prime of 3? Oh, no. this nasty function, negative 2 over 3 cubed, plus 6 over 3 to the fourth, plus 3. We're done. Stop. Stop. Isn't that numerical form? Could I plug this into a calculator? Stop. Do I have to simplify? What about the exponents? Stop. Just stop. That's in all numbers. All numbers. There's no variables. You can plug it into a calculator. Stop. That's the answer. But like, what is it? I don't care. You don't have to do it. Now, obviously, if it was multiple choice, you're gonna have to. They're gonna make you simplify that. Yeah. Last one. L. Is this L? Okay. Here's where you guys take an L. I'm just kidding. Not. Pi to the power of 3. Pi to what the heck is that? You know what? I don't care. It's some number. It's some number. Let me switch back to blue here. So f prime of x is just 0. This is a constant. Here's the main takeaway. Write this right here. Pi is a constant. Everyone sees pi and they freak out. They think it's a variable. No. No, it's just a number. It's approximately 3.1415. I have stage fright right now. 3.141592653. I think that's all I got. That's all I got, kiddos. F prime of x is equal to 0. And then obviously f prime of 3 is 0 also. Okay. Hey, that is the power rule. That's the power rule. That's what we set off to do in this video. How do I take a derivative of a polynomial? You're going to use the power rule, and I illustrated that here. I do have more complicated examples coming up in the next video, which you're going to want to watch, where we introduce radicals. Woo, it's radical, dude. Check it out, man. If you like this video, give me a thumbs up. Subscribe for some more awesome, wholesome math content. Catch you in the next video.